Good afternoon, everyone. Let's continue the rest of part of chapter 1. I believe we'll finish this chapter by today. So last time we talked about the operating system operations, resource management, security, and protection. And then today we'll finish virtualization and distributed system. So we think out this computing environment just to enhance it. But overall, it's easier to understand. Maybe virtualization is a little bit hard for you. And then we'll talk about some kernel data structures. So that means some important data structures will be used to explain the operating system algorithms and also will be used in your projects. And then we'll talk about different scenarios where we use operating system. That means it's related to computing environments. And then we'll talk about some free and open source operating systems examples. Let's start with the first one, the virtualization. So the famous company for this one is VMware, correct? So you should be able, maybe ever heard this one, okay? VMware. VM means virtual machine, okay, virtual machine. So why we want to have virtual machine? The most important thing is that currently we have hardware, we have a set of hardware, and then we already installed some operating system. So we said this is a host operating system. Okay, so it's a host OS. But you also want to run some other applications which has been developed for some other additional operating system which is different from this one. For example, your host operating system is Windows, but you want to run a Linux apps application. So how can we do that? You have maybe two choices at least. First one, you install Linux operating system on your hardware. That means you have a dual operating system on your computer, and then you can run in that operating system. Okay. The other one is that you don't need to install a new operating system because managing two operating systems sometimes have risks. Maybe you will have a problem in installing the new operating system on the same hardware. Maybe it will destroy, maybe delete or override the previous files. Of course, you only need to backup, correct? And the other one is that you can just consider, maybe I will develop a software which will be deployed on a lot of operating systems, different computing environments. So rather than we just have a lot of hardware in implementing one on each hardware, or we just install multiple operating systems on the same hardware, we can just simulate the running of that application on different environment on same set of hardware. So we can have virtual machine here, and then you can run your application which is combined for that new operating system. For example, you want to test whether this application is working on Linux as well. So you can install a virtual machine which is for Linux, from Linux combined. That means a combined Linux operating system which can be run on Windows. And then that means you already simulated that operating system running environment, and then you can easily run your application in Linux just for testing, right? And also it's easy for you to switch between, because you just stay within your Windows system. You can test both. If you have any problem, you can change the code and then compile and then run it again, correct? That's more convenient. So especially for development stage, which it would be easier for a developer to do this portability test. So rather than just have a lot of operating system installed in one computer and switch back and forth, because maybe you need to restart and then log in, okay, like this. That's not good. Okay, so this is the reason we want to have a virtualization. Okay, just want to simulate a running environment for a different operating system on a host operating system, which is based on the same set of hardware. Okay, this is the basic idea. In fact, for this one, we have two basic strategies. For example, here we can have another one called emulation. Okay, emulation. So in fact, emulation is also just like a emulation and virtualization. They belong to the same, just like a simulate. You can think about it simulate, but they have different angles. For example, how to simulate? Emulation is like we want to simulate hardware based on software. But virtualization, we just simulate the software based on software. So that means we just simulate the operating system environment. So that's different, okay? So that means the emulation is just used when the source CPU type different from the target type. Just let's look at, for example, like because I have worked in a company just as a software testing engineer. Finally, the senior software testing engineer. So my target is just test the integration test. That means not only just like a black box test. Finally, so we want to make sure when we integrate multiple modules together, we don't have any problem in the interoperability. Right? For example, when you are doing messaging, you have a call. When you have a call, you get a message like this interoperation. Okay, so sometimes we call the IoT interoperation test. So for example, how can we debug the code? In fact, I also work together with the developers together, because you know the hardware, right? So cell phone is like this one, but when you develop a code, you are doing the CPU, you are using the desktop, and then your cell phone, right? Your cell phone is just an embedded system. So your development environment is different from the running environment, right? So that means you develop here, but you compile and then get a binary code, and then we load it into the device and make it work. So the running environment is different from the development environment. So it's not easy to do the debugging, right? Debugging here. So how can we do that? In fact, at that time we use a device called OpenNI. So this one is like a simulation the hardware. For example, this software maybe can run on some general type of software. For example, like a Nokia, like a Samsung, okay? Like this one. So for this OpenNI, they can simulate different mobile phone hardware. Okay, and then when we are doing debugging, we can debug into the device to see whether this is a type of error related to the user interface, I mean the application, or related to the drivers, the hardware related things. Because this one we can help us think out, and also have a higher efficiency. Okay? You don't need to test, because sometimes it's not possible to debug the embedded system, because that's not easy to control the environment. Okay? For example, how can you send 100 message, okay, like that? So, but for here it's very easy. We can control. We can send 100 message and then in a batch mode to see whether there's something wrong. So in fact, here we use a software to simulate a hardware. This is called emulation. Okay, so this one is usually has a problem is slowest, because you can find even we can test here it works, but we still need to load into the target hardware to make sure it's really working. It's correct. So of course you first do the lab test, and then you need to do the field test. That means go to the outside. For example, go to the mountain, go to a village, go to a crowded city. Like this is called a field test. So for this type of things, we have a lot of issues to handle, correct? Because this is like a strategy for the embedded system development. Okay. So this is a basic problem is that one computer language not compiled to the native code. So the basic idea is that they are different, correct? Because we are not really combine a code which is the same code which will be run here. So this one is just like we run, of course we got maybe Windows is exe, but we run on this one, we make it get a bin. Bin means binary code. So that will be different, correct? So the reason is that the running environment is different. So this one is like a simulation of the running of the mobile phone software on this type of hardware. We cannot say 100% accurate, but at least you can filter out most common and apparent bugs, correct? So this is the most important reason why we want to use the emulation. Even until now, we still use this method. If you, for example, you have interest in mobile phone development, you can find Android or like Apple iOS and also some other, maybe Java's 1, J2ME, maybe in the previous one, maybe latest one, they have some new. But you need to have a simulator in their development system environment, the IDE. So that means you can choose different type of target mobile phones. Okay, different types. Maybe a different soft key, whether you have soft key or not, like those things. Okay, this is called emulation. We don't want to enhance this part. We want to talk about another one. This is like simulate hardware. We want to simulate a software running environment. So this is called virtualization. So that's why we mentioned here. We want to install a virtual machine here, and then we can run some we can say it's some executable, which was compiled on some other operating system. But you can simulate running on the host operating system. Okay. So this is a operating system natively computed for CPU running guest operating system, also native compiled. So here is like native means it's on the same hardware. That means OS native compiled for CPU. That means you have this host OS. This is your host. Okay. And then you can run guest OSs. That means once you have some virtual machine manager, you can run multiple. You can install multiple virtual machines. Each one will be used for one operating system. So you can run multiple guest operating systems on the same operating system and hardware. For example, you can run Linux. You also run iOS and maybe Solaris and so on, like a different operating system, your Unix. Okay. So this is like a running guest operating system, also native compiled. That means this virtual machine is like a simulation of the guest operating system. That means it's already compiled. It's a compiled minimum amount of functionalities which can make it work. Just already can run on your Windows, your host operating system. So here we give one example. For example, consider VMware. Running VMware is just the virtual machine software we mentioned. The company they develop the virtual machine that application, and then running Windows XP guest. So that means we want to run Windows XP. each running application or on native Windows XP host. Maybe this is not a so good example. Maybe we can change. For example, this is native is Windows XP. Okay, still maybe Windows XP or Windows 10. And then we run Linux. Okay? We can run Linux on this host operating system. That's maybe easier to understand because this one is seeming like the same. Okay. We can change it. Maybe that's better. So this one is running Linux. For example, running Linux. So XP is already too old. Maybe Windows 10. Okay. So make it to be the updated. Okay, like this one. Okay. You can install a VMware on Windows 10 host operating system. On top of it, this is only an application, is a software. It will, of course, this software will help you to deploy whether you want to use Linux or some others. So you have different VMware application. Okay, this one will run Linux guest. That means it will run Linux guest operating systems, and then can run its related applications. So that means you can simulate running of the Linux applications on top of Windows 10 based on the same hardware. Okay, so this is the basic idea. And then VMM, so it's a virtual machine manager. Of course, will manage all the virtual machines. Okay, so provides virtualization services. So that means we just communicate between the users and the virtual machines. Users of the virtual machines, of course, is software. Okay, is some application. Let's continue. For example, so here we have some use cases involve laptops and desktops running multiple operating systems for exploration or compatibility. Here we give some examples. I think in the beginning of this part, I already mentioned some of them. Correct? So here we set some use cases. You may have laptops, maybe desktops, but they will run multiple operating systems. Maybe you don't want to install multiple ones on the same hardware. Just want to run multiple operating systems. For exploration, so that means for maybe you want to just look at the code running on different operating system, whether it works, or sometimes you want to test whether this software is compatible. If we say is platform independent, so you must make sure it's really platform independent. So we want to test portability. For example, like this one, Apple laptop running Mac OS. Of course, that's usually we have this one. Mac OS. Of course, this is OS 10, OS X host, and then Windows as a guest. So that means you have Apple hardware. On top of this one, we run the Mac OS X X10, and then on top of this one, we run Windows. Okay. And then the other one is that this one you just want to explore. Want to explore. For example, this is very often maybe you want to use Windows software, but you have Apple laptop, which installed the Mac OS 10. Okay. For example, you want to Microsoft Office, use Office or PowerPoint or something like that. You can simulate this one, or you can have this one. For example, for developers. Developing apps for multiple operating systems without having multiple systems. So you can simulate multiple operating systems based on the virtualization. You don't need to install all of them. And then another one is quality assurance test, like I mentioned, applications QA without having multiple systems. So because you want to have efficient work. So rather than just install the operating system, maybe will destroy your computer system. So you can just use virtualization. It's safer as well because it will not hurt your previous operating system. And the last one is executing and managing computer environments within data centers. So in fact, this one is is very popular. For example, data centers, maybe it contains a list of computers. Each computer may be run on different operating systems. So we want to bridge the differences of all of them. For example, your computer is Linux. You want to communicate with other Linux, but if there's some data node is Windows, you can run Linux virtual machine there, and then you can still communicate with that Linux, with that Windows machine, right? So this is for cloud computing. Is very popular. You in cloud computing must use virtual machines. Okay, we want to run a heterogeneous. That means they are not the same configuration, same operating system, same hardware, same CPU architecture. They may have differences, so we want to hide these differences so we can use virtualization. Okay, this is the main reason, right? Main reason we integrate virtual machines in cloud computing environment. And then next one, we want to talk about, in fact, virtual machine managers can also run natively. So just like this one is like a software, like an operating system itself. So you install this virtual machine managers like you install an operating system, and after that it can be used to provide the services and the resource management to virtual machine processes. That means on top of this virtual machine managers, you install virtual machines. Each virtual machine will be used for simulating some operating system. Okay. So for example, like here we have this VMware ESX and the Citrix XIN server. So you can just take a look for this type of things. I think the virtual machine VMware was very popular. It's been very popular, very famous when maybe in the early stage of cloud computing. I think it's around 2014 or 15 during that time. Okay, now it's still important. It still has a large market for these things, but maybe it's almost just like have enough growth. It's like almost matured, right? Okay, so now maybe just like an operating system, kind of like Windows is already have a lot of great operating system products. Initially have a good market, and then people will just use it for a lot. So have a good market, have more people. So at that time it's very famous VMware. Okay. And here just give one example, just like how we run multiple virtual machines based on virtual machine manager. So if it's only one hardware, okay, one operating system is like this one. It's one hardware and then kernel. Kernel means your operating system kernel. So this is the host operating system kernel. For example, you use Windows, use Linux, okay, that's kernel. And then you can run only those processes on this one. For example, Linux for Linux, Windows for Windows. So you cannot run Windows on Linux, Linux on Windows. If we want to do that, we can do like this. Okay, we can run Linux, Windows, iOS, a lot of operating systems. So we need to use virtual machine manager. So you install, not just install operating system, you just install a virtual machine manager. So that means this is like a host. It can be native, we mentioned, right? So can run natively. So that means like you install an operating system. You install this one, and then you can simulate different operating systems by installing related or corresponding virtual machines. So VM1, VM2, VM3 virtual machines, and then we provide the services to run related or corresponding processes. So you run a Windows process here, run a Linux here, run a iOS here. Okay. So in fact, later we'll also give you some more important detailed instruction. I mentioned that you need to install the VM, the VirtualBox, and also the Linux virtual machines. Okay? So you can simulate running Linux commands or some programs on the Windows or iOS. Okay. So I think if today we have time, we'll talk about that one as well. So it's available on the book's website. Okay? I already asked you to install to prepare well for the computing environment. Okay, let's do some quiz for this one. This is just the virtualization part. The first one is the virtualization software is one member of a class that differs from emulation. True or false? For all the question, just true or false, or yes or no. Okay. So the answer is false. Okay. So they come from the same class, which is simulation, but just from different angles. Whether we want to simulate hardware or we want to simulate software. Okay. So they belong to the same, not this is a class differs. So in fact, the same class. They belong to simulation software. Next one, a virtual machine can be switched like a processed in the operating system. That's correct. Okay? We can, because this one virtual machine is an application, we can switch back and forth. So sometimes we want to enter the Linux system. Sometimes we want to use the host Windows operating system. So it's yes. And the VMware application was a virtual machine manager. Is yes, correct, because this is just what we have. We mentioned it's like we use this one as a manager to manage a set of virtual machines. Okay, VMware. Okay, let's look at the next one, the distributed system. In fact, in the previous edition, they put this one in the computing environment. So here we just have one slide to introduce this part. So distributed system. So we talk about different computer systems already. Okay? So we may have cluster system, distributed system. So what's the reason we want to have cluster system, distributed system? So one people cannot do all the things, okay? So we have a lot of people do the things together. That's why we need to have a organization like a company, okay? Like a government agency. So different people have different capabilities, okay? And then if we put a different people with different capabilities together, we make the organization stronger. So this is also the reason why we want to have a distributed or clustered systems. So we put a separate means each one is an individual one, okay? Each people is the individual. Separate, possibly heterogeneous. So that means we have different architectures for the computer system. Okay, still have a typo here. So this is we put a different individual one, but also maybe different architecture with different architecture systems together. But let's work together because we want to put them together. For example, all of us belong to the same class. All of us belong to the same university, same company, same country, same state, like this one. Okay? We have relationships, okay, and then let's work. Okay, let's work together so we can do something as a whole. Okay, together to access various resources within the system to increase. So this is the target. Okay, access various resources. Of course, resources can be storage, can be computational power. So we put different computer loads together, and then the reason is that we want to use their resources as a whole. For example, if we have multiple nodes within the same distributed system, although they are distributed in different locations, but they are networked together, they can communicate. That means if I want to use some, I have a network operating system or distributed operating system, I can find the related node to work for us. If I want to have a large amount of data to store, I have a distributed operating system or network operating system to distribute data to store in different computers. Okay? So this is the reason. It can increase, for example, this is talk about what's the resource, okay? Computational speed, because all the nodes can do the same task at the same time. So that means, of course, we can do the task, we can finish the task easier, quickly. Excuse me. And the next one is the functionality. Different computer node may have different capabilities. So sometimes this is for file surface, we can access file there, and this one is for the website server. This one is for calculation, right? This one is maybe for analysis, for algorithm calculation. So that means we can provide multiple functionalities, okay? And then the other one is data availability and reliability. So because we have a system of systems, so we can save the data in multiple locations. We have multiple replicates, and then we also have, for example, one computer system is down, and other computers can back up to continue the work. So that means reliability will be much better. Okay? So here we talk about how we network all the computer systems together to form a distributed system. So distributed computing is very popular. Okay? That's I think it's very general one. Even the same, okay, if the same, for example, Google have a lot of data centers. They don't do all the things on one computer. Okay? They do all the things in different data centers, on different computers, like this one. So distributed computing is very popular computing mode currently. And here, so we talk about it depends on the application domains, and then we have different type of networks. It's a pity you don't have a network courses. Computer networks is a very important course for the BS degree in computer science, because the network is everywhere, okay? Internet. But here I can only give you a rough idea, okay? Because we are not a networking course. But here network is just like you want to connect different computers together. Computers here is, you can say, it's like computer nodes. It can be a desktop, can be a laptop, can be a cell phone, even can be some home appliance, kind of like a refrigerator, maybe some other, or just like a microwave and so on, like these ones. If you use the cyber physical systems, so that means they are connected to each other. The reason is that we want to do communication. We want to do communication is for doing some business. Okay? For example, I want to remotely control something. I want to finish some business with some computers, and so on, like these things. And then for this communication, usually we have a lot of protocols. Communication, as long as you have a protocol, okay? What's the meaning for each message? What's the head? What's the content? And what's the ending part of the message? So we need to wrap up these packages, messages. So we send this package from one computer to the other computer, and then on the other side they need to, first one is the encode, the one is decipher. Okay? Just want to see what's the meaning. So that means as long as they follow the same protocol, they will understand the meaning. Okay? They will understand the contents. So usually we have TCP/IP. You may have heard this one before, okay? So that's here it before. TCP is transmission control protocol. I think it's that one. Transmission control protocol. And then another one is IP, is internet. Internet protocol. Okay, this is two. So TCP/IP, they have different level. TCP, I think it's 5 layers. IP should be 7 layers. I believe 7 layers. So that means they have maybe TCP is 3 layers. You can just have a look. I already forgot some of them. So that means this is the basic idea. That means how we communicate with different computers. We based on this most prevalent protocols, TCP/IP, based on this one. Okay. And here we talk about. So we said that we form a network. So here we talk about different type of networks based on different scale of the communication. You can have a local area network, for example, your home. You connect all the computers together, or your lab. You connect all the computers together. File maybe hub, maybe some router. Okay? So you need maybe hub can connect all the computers together. You form a local area, and then you use a router to communicate with other networks. Okay. So use a hub, you can already connect all the computers together via the cable. Okay? That's easier. And then you connect this cable, the output to the input of the output of the router to the input of this hub, and then you have a multiple output. Okay? Just like this one, you have input. This is the router, and then you have hub. But the hub you have a multiple out. Okay? Each one is a computer. So that's a hub. So this. All of this one will be a local area network. Okay? That means you connect multiple computers together. Okay. And then we have a larger scale. For example, we have a wide area. For example, like we have a campus, we have a company, we have a city, we have maybe larger one. Okay? And then even larger one, we have a metropolitan area. Okay. For example, the city and the related suburbs, we have metropolitan, and then we have also even smaller one called personal area networks. For example, if you just use your laptop and your cell phone, you connect together. This is your personal area network. Okay, very small. Use a hotspot. Okay, and so on. Okay, hotspot like these things. So that means you just communicate, construct a very small scale network. And then we also have a network operating system. So this network operating system will be used to provide such functionalities. Okay? Manage all the all the hardware, even they have different operating systems, and also they can communicate, they can handle the jobs. So provide features between systems across the network. Communication scheme allows systems to exchange messages, for example, like communication. This one gives us an illusion of a single system. So if you install, for example, like Windows NT, Windows NT we heard before, and then this is for network operating system. You run this one, you can access other computers, just like you use the same computer, local one as yours. So give us a single. You have had all the differences of different computer systems that are connected together. So you can just run the same. For example, you want to run the task on the network. Okay, they will just do the things. They will find out, okay, what's the load balance among the nodes and how to combine the results together after finish. So all of these things will be handled by the network operating system. You don't need to care about those communication and job scheduling, job dispatch, and results combine, and so on. They will handle these things. Okay? So that means for different purpose, we did have different type of operating systems as well. This is just tell you this one. Let's do the quiz for this one. There's only one slide for this part. It's pretty easy. Okay? Let's look at first one is the Bluetooth and 82011.11. This is a wireless protocol. Bluetooth is also one type of wireless. Okay? Use wireless technology to communicate over several feet. In essence, creating a local area network, wide area network, small area network, metropolitan area network. So local area network means the unit very small, okay? And wireless unit, it can be bigger, can be smaller, okay? We don't know. So that means because like our campus, okay, we cannot say the local area like a lab. So that means use this one. This one unit is for small, local, very local. But this one can be used for yeah, of course. This one also can be Bluetooth. You can also do like that. For example, you have Bluetooth, and then you connect with desktops by Bluetooth. You can also get a bigger one. But the unit, because this is wireless one, they cannot have a very wide one, okay? So based on this Bluetooth and this one, it can help us to have a small area. Means it can be a bit little bigger than local area, like one lab. They can have a bigger one. Use wireless first, maybe, and then use Bluetooth for very small distance. For example, only 10 meters, and wireless for larger coverage, larger area coverage. So that means we combine the two together, we can have a small area like maybe a campus, kind of like our campus. Okay, even we don't have cable, we can also use wireless to connect. Maybe, okay, at least maybe if it's strong enough, you have the coverage, okay. And they are a fixed number of network protocols. So this one we didn't mention in detail, but in fact we mentioned only two examples, TCP/IP. But in fact, you can have your own protocols. You can have, we can call it just prescribed network protocols, because as long as they follow the same protocol, they will know the information, cut. So we don't have a fixed number of network protocols. You can have your own. You don't need to follow the standard one, cut. So there's an infinite number of, in theory we have infinite number. And next one, internet. So this is no, cut. And then next one, internet is a network of networks. This is cut. So network, we connect all the networks together. Okay, of course if they want to connect. So we got the internet. Okay, this is the this part. So next one we'll talk about the kernel data structure. So basically for this one, we don't have slides here. So we'll go over the contents in the book. Okay, the online book. I have the digital online book textbook, and we'll cover this list, stacks, queues, trees, hash functions, and maps and bitmaps. Let's go this one quickly. Okay, don't want to go it in detail, but we'll go for it quickly. So list. So here we usually use linked list to simulate a list. Okay, for here. Of course, you can also use array. You don't have to use this one, but here it just give some example. If we want to use a linked list, will be like this one. So list is like you connect. You just want to combine multiple things together, okay? Represent a collection of data values as a sequence. Okay, like this one we have a singly linked list, so you can only go to the next. And then you have a doubly linked list, so you can go to next or prefers. So from each node, if there's a prefers node, we can go to the prefers, so they are connected to each other. So from any node, you may go to previous node if applicable, or next node if applicable. Okay? So this is the doubly linked list. And then we have a circularly linked list. So it's only difference is like based on the singularly linked list, we also connect the last one and the first one. So we form a circle. Okay? So that means the next will be the first. Okay? So this is called a circularly linked list. Okay. So based on this, we will go over the data structure contents you have learned before. And the next one we talk about stack. Okay, stack. So stack is a sequentially ordered data structure that use the last in, first out. Okay, a stack, last in, first out. So this one is important for our operating system. We want to record the order. Okay, record the order. So that means, for example, we push something into the stack, and after that we pop it up, and then we need to know the order. Okay, so you only have two operations. One is push, the other one is pop. So push, of course, if the stack is not full, you can push. Push means you add one more. Okay, move all the items in the previous stack by one down. Move down by one, and then put the current one on the top. And the pop will be just remove the first one, and then let all of the remaining ones go up by one level. Okay, this is the pop. So in fact, we can simulate this data structure using maybe array. Okay? Use some other methods using linked list is also possible. So that means you need to know how to implement this data structure as well. Of course, maybe in some program language they already have the classes definition. Then you can use it directly. Okay, and then queue is similar like the stack, but the mechanism is different. Queue, first come, first serve. Okay? So it's first in and first out. So that's the difference. Okay. So items are removed from a queue in the order in which they were inserted. So that's important. For example, like a job scheduling, if we based on first in, first come, first served method, we need to maintain a queue. Okay. And then if we want to use the last in, first out, for example, we want to develop this scheduling algorithm. You first come, but it will be lastly scheduled. Then we need to use stack. Okay? So these data structures are very important for those things. If you have any problem, go for them. Learn by yourself. Okay. We also have the text here. Maybe you don't have. You have text as well in the book. Okay. So it's a lot of very detailed or very heavy usage. But sometimes occasionally we use it, and also we use them, and also maybe the basic usage, not very complicated ones. So the basic concepts and how to implement them, that will be the important thing. And the next one we talk about a tree. Tree is also a very important data structure for our operating system. For example, like our file system, we want to maintain a tree structure. Okay, so tree is like this. Okay, like this is a data structure that can be used to represent the data hierarchically. So tree has an important thing that any node can have at most one parent. You cannot have one node which has two parents. Right? You cannot have this one. So one node can only have at most one parent. Okay, and then we set the left join one on the left with left child, right one is right child. That's for binary tree. If we like this one, called binary tree. And then we also have another data structure called binary search tree. So binary search tree, of course, is a binary tree. That means each node can have at most two children. left and right. But also binary search tree has this property. You must follow this rule. The left child is smaller than the parent. The right child is larger or equal. I didn't put equal, okay? At most, okay? This one is less or equal to the less than or equal to the parent. Right one is larger than or equal to the parent. That's called a binary search tree. So that's why, for example, binary search tree will make it easy for us to do the search, okay? Because you can just go every time you will just trim the tree by 1/2. So whether you want to take left or take right, you just compare with the node. If it's less than this one, you must go to the left branches. If it's larger than this one, you want to go to the right branches. So each time we will just get rid of 1/2. Okay? So it's like you have n nodes. Each time, each search, each step, you will reduce it by half. So how many times you need to go to reduce the original number n to 1? That will be log n. Okay? So from n, and then you have n over 2, n over 4, n over 8. So how many divisions you will reach 1? So n is equal to 2 to the power of log 2 to the power of n. Okay? So you got this power will be log n. So that's log n. So you can find that now the search is much quicker. If you want to search for some values, initially if linear is like that one, okay, you need to do one by one n times. But now we only have log n. Okay, log n. Okay. So this is the reason the performance will be good. Okay? At most log n efforts. Maybe you don't need to reach the bottom, okay? Reach the leaf node to find that node. You may just reach something in between. For example, you want to find 35, you will find it here. So the worst case performance is big O of log n. Okay. And also we have example. For example, Linux, we use the red-black tree. Okay. Just take a look if I'm interested in this one. Red-black tree is also a binary search tree, but we use red and black to differentiate nodes. Okay, next one we talk about hash function. So hash function is just like we want to map the data to some locations, and then we want to retrieve that data in a more efficient way. So we use a hash function to calculate the location. Okay, so that means we want to save data into array. Okay, we can calculate the location based on the key value. Key means the data. Okay, so it's take data as an input, perform the numeric operation on the data. So that means the numeric operation is the hash function. Okay, data is the input is x. For example, y equal to f of x. So the x is the data, f is the hash function, y is the location where you will save the x. Okay, this is the idea. So that's why we call the hash function key. Key is the data, and then we save the value into this location. We can retrieve the value. You may just select some key of the data as some part of the we select the key, okay? Some part of the data as the key. For example, you want to save a record of a student, you can use the ID, okay? You don't need to use the whole data, because the record of the student maybe contains a lot of things. ID, first name, last name, and which year, okay? And the GPA and so on. But you use ID, okay? Key, just like a database. Which things is the most important one you want to care about, then just use that one. Okay, and then after you get this one, you calculate, okay, it's this location, and then you can retrieve that data, get the value. So this is the idea. If you don't design a hash function, maybe you have this issue. For example, two different elements, they will map of course you select the keys, okay? After you perform the hash function operation, they will map to the same location. So we call this called hash collision. So we need to develop a rule how to handle the hash collision. So that means you can find the location. So this is another thing we need to look at. Okay, next one we want to talk about bitmap. So bitmap in fact is a string of n-binary. Bit means binary, okay? N-binary digits, just like this one, 0010, like this one, okay? Can be used to represent the states of n items. For example, like the process management, we have this one. We have resources. For example, we have printer, we have a desk, we have a screen, we have a file or something, and then how many piece of resources for each of them. We use these values to represent. Okay, but here use binary. But sometimes we don't use binary. We can use numbers, like this one. Okay. But here we can use this one to represent whether some resources is available. For example, this is resource 0, resource 1, 2. Okay, this one, if it's 1, we here we say 1 is unavailable. Okay, that means whether it's unavailable. And then 3, 4, 5, 6, 4, 5, 6 also unavailable. And then 7, 8 is unavailable. All others are available. So this is just like a bitmap, okay? Bitmap, just like a series of bit binary digits. Okay. This is okay. Let's do the quiz. Okay. So this one should be easier. A stack is a sequentially ordered data structure that uses first in, first out principle for adding and removing items. Stack is first in, last out. Okay, so that's a no. And then what happened? And then in a binary tree, a parent may have at most 2 children. Binary tree, of course, a parent can only have at most 2 children. Okay, this is no. And this is yes. Sorry, we need to use yes. This is true. This is true. This is yes. And the next one, hash collision, refers to the phenomenon that of a hash function in which 2 unique inputs result into the same output value. That's yes. That's yes. Okay. So this is the for this part. Okay. So next one we'll talk about the computing environment. Okay. Of course you can stop for a while. Usually I will not stop till I feel tired, but you can stop for your learning any time. And next one we'll talk about the computing environment. So for here, computing environment, that means while we use operating systems, what's the environment we use the operating system? We install operating system for which type of computing environments? This is important for us to consider, for all the things functionality related to operating system, resource management, security, protection. Because for the environment is different, their operating system requirement also different. Okay, so we have these 6 types: traditional computing environment, mobile computing environment, client server, so CS mode, CS computing environment, not what's that one? CS Counter Strike, that game, not that game, not CS. P2P, P2P, peer-to-peer. So this is also quite popular now. And the cloud computing, of course, very hot, very important now. Cloud computing. And then real-time embedded computing environment, computing system. Also important, like our cell phone. Okay, embedded system, also real-time. So first one, let's look at the traditional one. So traditional operating system is easy to handle, just like you have a traditional desktop, and this one is used for yourself. Okay. So you need quite a standalone general purpose machines. So even you don't need to consider whether you have network or not. Okay, just consider this one. But the traditional one, you need this one. We have different meaning now. Okay, traditional now is like only you use the computer itself. You don't use network, and then we said it's like a traditional one. Each one is in the individual system. But now I think all the computers most computers are connected. Okay? So this is blurred because most systems interact with each other via the internet. Okay? And then we can use the portals. Portal is like a gate. Okay? It's a gate provide web access to internal system. So you may have your own company network system, and then you use some servers as the portals. So this is the gate. So you want to go outside, you want to get some service from outside, you will based on the servers. So we call it portals. And then we have network computers now. So usually it's like web terminals. Okay? They are thin clients. So that means they don't need to be very strong. They just need to provide, for example, interactivity, very moderate computational power. At least can do some very easy calculation. But the most important heavy calculation will be done by the network, okay? By the server as well. Okay. And then mobile computers interconnect via the wireless network. So even mobile computers, it also connect with the network, with the internet via the wireless network. So that means we don't have a real purely defined or pure or original meaning traditional computer. Okay? And the networking becomes everywhere. Even for example, home system will maybe use firewalls to protect for safety, security, protect home computers from internet attacks. So this is just tell you that means all the things are connected to each other. Okay? And then let's look at the mobile computing. So mobile computing is just for handset, smartphone, tablets, the ones, the computing environment for those things. So what's the functional difference between them and the traditional laptop? Of course, this is the special one, okay? Because you have that mobile. That means you want to do it everywhere, okay? Everywhere. So they will not do very heavy calculation. They will do some simple ones for communication, for easier things for those things. And also they are different. Is like they use wireless. Okay? They don't use laptop. Usually we still can use wireless, but usually we put a laptop in some locations. We fix. Okay? But cell phone we can bring cell phone everywhere. And that's the computing environment. The usage environment in different scenarios will be different. They have actual features. Then they may have some other operating system related features. For example, like GPS. So that's the related thing. That means we want to use it outside. We want to do this positioning. So we need to install these things. And gyroscopes, like these things. And then a lot of new types of apps like augmented reality AR. So that means they can install different applications on those mobile devices. For example, you can use this one for payment, okay? And you have mobile apps, and some banks also have apps. You can do the business in a remote way, okay? In a more convenient way. They use this wireless protocol we mentioned before, 802.11, or data communication networks, For example, like we use 5G, 6G or something in the future. So it's a cellular data networks. So this one is about data communication or wireless communication. They use different protocols, okay, for connectivity. And the operating system for this one, the most famous one is Apple iOS and Google Android. These two, right? In the past, we have Java J2ME, Java 2 Microsoft edition, Micro edition. But now we think dominated and will be these two, okay. And the next one is the client server computing environment. Okay, so some may be client, some may be server. This is called a client server. So that's easy to understand, okay? So so basically it's like a list of clients. We access the surface from a server via a network. For here, we give two examples. First one is compute server systems. So this one is just for some services. That means we want to do some request some services, not only just save data. Okay? So different from this one. So next one is file server system. This is compute. We then like retrieve some data or save update some data. That's called compute, still computing. But for this one is storage, provides interface for clients to store and retrieve files. So it's only for storage. That is file server systems. Okay, this is CS. Both are CS mode. And the next one is P2P. So peer-to-peer for this type of system is the latest one. So people use this one, just want to improve the reliability and also speed as well. So let's look at what is the P2P. This is another mode of distributed system. So in the previous one, we have a client and a server. Okay? Some are worked as a client, some nodes are working as a server. But for here, we don't assign like that one. So instead of all nodes are considered all nodes are considered peers. So they can be clients, they can be servers, they also can be both. So that's the difference. Okay? May each act as a client, server, or both. So that's the difference. We don't differentiate client and server. That's why P2P they're the same. Okay? They're the same. They can work as a. So sometimes you are client, you want to request service from others, but you also provide service to other clients. That means you are working at both clients and server. Okay? So here we have two types of P2P network. So the most important thing is that because here we don't have server and we don't design it server and client. Okay? So we need to understand how to do the communication. So here we have two strategies. The first one is called type 1. I give a name called type 1 to differentiate from the second one, type 2. So this one will register each client, okay, each peer's service with a central lookup service. Okay, that means we maintain a table which registers, which save which client can provide or which peer can provide which type of service. So when we need to get some service, we can look up the table and then we find some client and then we request the service from that client, okay, or multiple clients. This is the first one. That means we used to look up service. The second one, we don't do like that. We don't maintain a lookup service table. We just do it like this. When we want to have some service, we will request for some service, we send a message in a broader way, use a broadcast. okay, message. So we send just like a radio. I ask everybody whether you can do this. If somebody can do this, they can acknowledge. Okay, use ACK, acknowledge signal, and then answer. Okay, I can do this, and then they establish the communication link, and then they can finish the service. That's the idea. So just like broadcast the request for service, and then response to request for service via the discovery protocol. Okay, this is type 2, broadcast based. This is lookup service based. So we have some examples. For example, like the lobster, you can have a look at the detail about this one in your book. Lobster is type 1, and then we have Nutella is type 2, and then we have many VoIP, VoIP, voice over IP. That means via the internet we do the telephone or just voice video, voice and video. So like a Skype, Skype has both type. It's a hybrid way. It's not only type 1 or type 2. They use both. Okay, it's maintain a lookup service table and also have broadcast request. Okay, so that's how they build their network. They use both ones. Okay, both ones. So next one is cloud computing. This one is famous. Its usage is a very hot application or computing mode. Okay. So the definition for this one is delivers computing, storage, even applications as a service across the network. So that means that you can request some service via network, and then the other side will provide this service. What type of service? You can do some calculation, store some data. Even you want to use some application softwares, they can provide such things. So like the Amazon, okay, EC2 and Microsoft, we have Azure, and then we have a lot of cloud service now, okay, providers. So this is a logical extension of the virtualization. So in fact, you can think about it, if we collect all the computer nodes together, each one, even though they are heterogeneous, they are different hardware, different operating system, but you can use the virtualization software to hide the differences, and then they can provide the same services to you. Okay? So we can use this one to combine, and then make it even more stronger. If you have a very time-consuming calculation, we can divide the task among a lot of nodes, and then you can, of course, it's just a request based on leads. Of course, you may need to pay more. For example, you want to have 1,000 nodes, okay, and then how much time you need to finish, and then they will just calculate the quota for you. So this is just like this one, okay. So virtualization will be important for cloud computing, right? Because they use the virtualization as the base for its functionality. I think this is a typo as well. So I will also upload this latest slides after finish this lecture. Okay. So here we give Amazon EC Elastic Cloud 2 has thousands of servers, a lot of servers, millions of virtual machines. They can simulate a lot of operating systems, and the millions of virtual machines can provide a service for many users. Each one may be provide service for more, for not only one users, and they have petabytes of storage available across the internet. So that means they can do computing, storage, computer storage, and also maybe servers. They may provide some software as well. Later we talk about different types of cloud computing services. Okay, based on the internet, pay based on the usage. Let's look at the different types of cloud computing. Here we have three different concepts called public, private, and hybrid cloud. Public means everybody can access the cloud service by internet. Private cloud means they can only used by some organization, for example, like a company. Okay? And hybrid, that means they have both. It includes both public and private cloud components. So some provided for everybody, some usage within the organization. And then we have different types of cloud services. Okay, the first one is the software as a service, SaaS. You want to use the software, okay? For example, you are now using Linux, but you don't want to install Windows Office. You don't want to install Windows, or just use a virtual machine run on your computer. You don't have enough storage or something. You can use internet. Okay? They can have online cloud service. You can use those online version. In fact, this is provided as a software as a service, SaaS. Okay, one or more applications available via the internet. For example, like word process. And the other one is a platform as a service. You don't have only one or several. You can have a lot of software as a whole. We call it software stack, ready for application use via the internet. For example, like a database server. You have Oracle related things, you have MySQL related things, and so on. So they provided a set of software for a purpose or application domain. So you have a stack of software. So it's like they already prepared a platform for your applications, okay, for your usage. And the last one is even high level, kind of even more comprehensive, well around. Infrastructure as a service. You can use the whole server, okay? The servers or storage available over internet. So like a storage available for backup usage. So this is infrastructure. They maintain the mechanism for you to use the servers or storage, okay? So this is called infrastructure. You are not do computing, or you want to do computing, you can find both in this example. Okay. So that means it's like you give you a computer, you can save data there. You can also run your application there. So you just like you rent a node or several nodes. Okay, this is the cloud computing. Another example here. Okay. So here, cloud computing environment composed of traditional operating systems. So we have traditional operating systems plus virtual machine managers. Okay, we need to hide the differences, hardware differences, operating differences from the users. Okay, we need to install this one. Plus cloud management tools. This one will manage the following things. So that means we have a cloud computing tools. So we didn't put there it here. So this one will handle load balancer and other services. Let's look at internet connectivity, requires security like firewalls, like these things. So this one will maintain. Okay, we'll send the cloud management commands to a cloud customer interfaces, and then manage the firewalls. Make sure it is safe, okay, to communicate data between internet and this cloud service system. Okay, and we'll have load balancers spread traffic across multiple applications. If you receive a usage application from a remote user, and then you want to balance the load among a lot of nodes, okay? So you don't want to use only one node to calculate for a long time. So you need to have load balance. So for distributed computing, unit that will be issue, storage, and job scheduling. So for this load balance, okay, because it's a large scale, unit large scale computing, you have a lot of resources, so you need to manage those resources in a balanced way. You don't want to have this case some nodes are idle and some nodes are keep busy. That's not good. And then last one we'll talk about real-time embedded system. Just use one word to describe this one, is that if time is a critical concern, so that will be real time. So you must finish some tasks within a prescribed time, multiple time. This is called a real-time embedded system. The most prevalent form of computers, for example, like they have very considerable special purpose, limited purpose operating system, real-time operating system. Okay, we call this. And use expanding many other special computer environment as well. Some maybe have operating system, maybe don't have. For example, like your car have an engine, they have some real-time embedded system. They must finish something within a small amount of time. Right? If you ignite the car, they must finish within a small amount of time. You cannot let the spark run for a long time. Okay? You must spark a while and then stop, and then break, and so on. Like these things, they will handle the time. Okay. So real-time operating system has a well-defined fixed time constraint. That's the most important. Real-time, that means finish as soon as possible, and also have the time constraint attached to each task. Of course, even is depending on the priority, which one has the highest priority, and so on. They have the time constraint accordingly. So processing must be done within constraints, and correct operation only if constraints met. So that means we don't only look at the results, but also look at the time. Okay, let's look at the quiz for this part, and then we may have a rest. So quiz 1. Embedded computers typically run on a auto operating system. Embedded, that run on real time. Okay? Windows XP network cluster, real time. Which of the following is a property of a peer-to-peer system? Which of the following is a property? Okay, for P2P. So clients and servers are not distinguished from one another. B. Separate machines act as either the client of the server, but not both. C. They do not offer any advantages over traditional CS systems. They suffer from the server acting as the bottleneck in performance. So this is CS. Cat. This is not offer. They do offer some advantages. Separate machine act as either the client of or the server. I think there's an arrow here, but not both. They can do both. Okay? So A is correct. Client and servers are not distinguished from one another. Okay, and then what? Provide a file system interface which allows clients to create and modify files. So that's easy. File system interface, that will be file server systems, because this is only for file, for file storage, retrieve, update, and these services. Okay, let's. I think we have only one part finished. Okay. Let's finish this one anyway. That's better. Okay, the last one. So there is free, or sometimes we call it liberal. Okay, free or open source operating system. Let's first clarify these two items. What is free? What is open source? Is they equal? Are they equal to each other? The meaning? Free is free. Open source maybe not free. Okay, free of course will be just usage for free. Right? They may have open source, maybe not. But open source means that I will have just provided the code only. Right? Only for code is open source. But maybe the usage not free. For example, using this Windows, using this operating system, maybe not free. The software, the source code is free for you to study, but maybe usage is not free. Okay? For example, for some distributions, they may need to pay. Okay? Let's look at this one. This one maybe is only one slide, I believe. Yeah. So, operating systems made available in source code format rather than just binary, closed source, and proprietary. So this means usually if we set the operating system made available in source code format, that's called open source. Rather than like, for example, if you have a computer purchase one and then they pre-install some operating system, that is binary one. So you don't know the source code. Okay? You need to use the we call it re-engineering. Okay? I think it's called re-engineering, and then you can reverse engineering. You can get some code, maybe from the binary code, get a source code. It's called reverse engineering. But you cannot get all of them. Okay? The commands, you cannot recover them. And then this is open source. For this one is counter to the copy protection and DRM, digital rights management movement. Just want to make the code available for everybody. Okay? This open source is started by Free Software Foundation, which has copyleft GNU Public License (GPL). Okay? So free software and open software are two different ideas we mentioned before, okay? Championed by different groups of people. So can look at details here based on this GNU organization. And the examples include GNU Linux. So based on this license, we have this Linux, and the BSD Unix. So BSD Unix is a Berkeley version, okay? Berkeley 1 Unix. This one including the core of the Mac OS 10. The core of Mac OS 10 is called Darwin. Both of these BSD Unix and the Mac OS X, they are like a Unix type operating system. They contain the core part is called Darwin. Okay. And can use VML, can use virtual machine manager like a VMware player. This is free on the Windows, or VirtualBox. Okay, this one is very important. We use VirtualBox in our courses as well. So this VirtualBox is open source and free on many platforms. So you can download from here. Later we'll give you some instruction about this one. This one can run guest operating system for exploration. For example, you want to run Linux on your Windows, Linux on your iOS, and so on. This one will be great resources. In fact, in the book, we have detailed description about some cases, about their history, their features, their URLs. So you can just have a look at them. So with like Linux, GNU Linux, and BSD Linux, BSD Unix, and then you can, and even Solaris. Solaris may be a very short description. So because we are using VirtualBox in our system, in our course, we look at this one. after we finish this quiz. Let's look at quiz. So for this one, maybe we'll go over it quickly. This is about a study of operating systems. There has never been a more interesting time to study operating system, and it had never been easier. The open source movement has overtaken operating systems, causing many of them to be made available in both source and binary executable format. So this means currently we have a lot of resources for us to study different operating systems. For example, here we list some of them, like Linux, BSD, Unix, and Solaris, and part of Mac OS, means they are core part, the Darwin. So here we have a link, list all the currently available open source operating system projects. Okay, if you click this one, you can find the projects. Okay, just look at these ones. Not okay. I think I also mentioned about this book. The one book you just look at the detail about FreeBSD. Just the kernel. Look at its kernel study. Okay, just take a look about this one. So it's good resources for you. Just you can look, if you prefer learning operating system course by looking at one example or several examples. For example, you have interest in iOS, look at this one, Darwin. If you are interested in Linux, you can use as Linux, like these things. Okay, or some Unix system, you can use FreeBSD or some GNU BSD. Okay, this is a one. And then in addition, the rise of virtualization as a mainstream and the frequently free computer function made it possible to run many operating systems on top of one core system. We know virtualization. The advent of open source operating system has also made it easier to make the move from student to operating system developer. So that means that even our student can do the operating system development, because you have the source code, you can change, you can combine get different modifications, have some accommodation for your personal usage. That's why Linux is very important operating system in industry, because it's open source, it's safe, everybody can do, can look at the code, and then you don't have any concern. And also you can accommodate the Linux to your own target operating system. You change it. Okay, let's look at the quiz. First one, which of the following statements concerning open source operating system is true? So it's about open source operating systems. Which statement is true? Solaris is open source. Next one, source code is freely available. They are always more secure than commercial closed systems. D, all open source operating systems share the same set of goals. So let's look at source code is free. Source code is freely available. This is correct, because it's called open source. That means, of course, okay, source it's free. Yeah, the code. Yes, the code is free. The code is freely available. That's correct. So this is they are always more secure. We don't know. Open source operating systems share the same set of goals. Different operating systems have different goals. So real-time network and the desktop, all of the different type of operating systems have different goals. And B is correct. This is wrong as well. Solaris is also not open source. Okay, which of the following operating system is not open source? So Windows is not, so it's not open source. So till now you don't have open source or have all the code available. BSD Unix is available, Linux is available, PC Linux OS is also available. And And the next one, A is a custom build of the Linux operating system. So which one is a custom build of a Linux operating system? That's a distribution. Okay, that's easy. Okay, that's all for this chapter. Okay, that means we already finish this chapter. But in fact, even in the book, you can find when we talk about the GNU Linux, in that section 1.11.3, we also have the, if you look at the book, 1.11.3, about this one. We also talk about virtual machines. We also talk about VirtualBox. So I request you to finish preparing the environment by following the operating system website for this one. So that's this one. You click this one, then you have this one. Okay, I just save my time. So that will be, you need to follow these steps to install each one by one. Okay, so basically the first step is that you need to install VirtualBox. So for target for here, that you want to run command line, command line based Ubuntu server running version 4.4 of the Linux kernel on your target operating system, whether it's Windows or Mac operating system, okay, or anyone. So your first one, you need to obtain VirtualBox and then install a virtual machine and then run in Linux and then exchange file between host and virtual machines and exiting. So that means first the following steps. I may just teach you some important ones. First one, you download this one. Click this one to download. Okay, this will be easy. You will click. So I already clicked download this one. So that will be textbook. Linux programming text. Yeah, it's here. So you download here and then you double click this one. Okay. So sorry, you need to download this one first. So download the VirtualBox first. VirtualBox. So you click this one and then download this one. I think they will recognize your operating system. If it's wrong, just change it. Okay? Download this one. So I already download this one. VirtualBox for Windows. Okay. And after that, you need to install the VirtualBox first. So download this one and then install. Okay, install. So that's a VirtualBox. Once you install, you have this one. You don't have this part because this one will be after you install the virtual machine operating system Ubuntu here. Okay. So here, after that, you download this one. After you finish, you get this file, osc10e.ova. Right? So this is the virtual machine, and you double click this one. They will open the following window, like this one. Let me double click. And then you can import. Let me import this virtual machine into the VirtualBox. I think initially I have done this one. Okay, so this one takes a little while. Okay, and then after that you can run the Linux. Okay, I think I can stop because I have done this one already. So after that, You got this one, same as this one, okay? And then click the start. Okay. So now you have, that means now this is running the Ubuntu in your Windows operating system. Okay. And then the default username, I think I already logged in. Okay. And then you can do the following things. For example, if you log in and then if you use ls, this is a Linux command, okay? Just list all the files and the current path, and then you can find these things. Just check whether it works. And then you can also use this one. You download a file from website. For example, this one I want to download all the source code from website. So you just input these commands, and then it will download. I also tried, it works. Then no problem. And exiting. Okay. So later we'll use this one to run some experiments, and then you will know, okay, why we need to do this one. Okay, so this is the important thing we want to mention in this chapter. So this chapter is a long chapter. We spend a lot of time in this one. The most important reason that I want to give you a very detailed overview, and this will help you understand the later chapters. Even we cannot cover all of the contents, you still have an overall picture. You have a solid background. This is like a foundation of a house you want to build. Okay, that's all for this chapter. I think we have some time left, and then we continue with chapter 2. I will confirm whether we have time. Okay, let's upload this one first for you.